Alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now exams are just around the corner and we are doing topical revision. So now let's start with some 2023 papers. Let's look at the most recent past paper questions related to differentiation, related to integration. I'm not focusing on 2024 because those yearly past paper videos have been recently uploaded. So that would be kind of too much of a repetition. So I think 2023, it's worth all the respect that it deserves. So now we are starting at 7:30. Let's take 1 hour because then I'll be doing the February-March 2025 solution also. So now these two things will be uploaded as two separate videos. So my focus will only be on differentiation. My focus will only be on integration. So let me look at this. Let's look at question number 8. So question number 8, it says the functions f and g are defined as follows, where a and b are constants. Now, let me write few things on the sidelines. And that is when we talk about differentiation and when we talk about integration, no one ever has any doubts if they are taught by a proper teacher. Related to the rules, everyone is very, very comfortable with the rules. But the main issue is about the simplification thing, because not everyone is fortunate enough to have studied O-level or IGCSE with a lot of clarification. So now that simplification related to algebra, related to LCM, about factorization, about expansion, about indices, that is the game changer. So if you know the stuff in and out, only then you will be successful in this thing. So now let's look at this working and let's see how much of it is true. So now this is functions. I think there was a part of differentiation. My bad. That is not this one, this one. So now the rates of change, let's talk about it. Water is poured into a tank at a constant rate of 500 centimeter cube per second. So centimeter cube per second, that is rate of change of volume. So with respect to time, definitely. So this is dV by dt. And what is the question all about? It's about rate of change. The depth of water in the tank t seconds after filling starts is h. When the depth of water in the tank is 8 centimeter, the volume of the water in the tank is given by this formula. So they have a formula of their own. Sometimes they can talk about a sphere. Sometimes they can talk about a cylinder, all those basic things. But over here, they have given a formula of their own. First part, find the rate at which h is increasing at the instant when h is 40. Now, what are the things that you need? First of all, jot down the information. So jot down. That is very, very important. Don't always go to the top and look at things. Whatever things are there, just jot it down. So over here, this thing is jotted down. That is dV by dt. Then we have the volume equation. Volume is 4/3 this thing minus this thing. The derivative of a constant is 0. The derivative of this thing is this power comes down, multiplies with this constant, bracket remains as it is, power reduces by 1, even if the derivative is 1, write it. Because when the derivative is not 1, you will forget. I can tell you from my own experience and from the experience of other students. So this is dV by dH. Plug in h is equals to 10. We get a numerical value. No need to simplify at this stage. You can write it like this. Volume is dependent upon height. Height is dependent upon radius. In other words, volume is dependent upon radius. So now when volume is dependent upon radius, therefore dV by dt. So let me highlight this. dV by dt is dV by dH into dH by dt. So now this is given. This is plugged in based upon basic differentiation. You make this the subject, leave the answer in the fraction form. That is the first thing. The next thing. At another instant, that means when it says at another instant, one other thing, this first paragraph is valid for the whole question, but now h is not 10, h is something else. At another instant, the rate at which h is increasing is this much. So now this time dH by dt is 0.075. Now a lot of people are in doubt. about whether this is true or not. So now, is this part of first paragraph? Yes, this is part of first paragraph. So the first para thing is applicable for part A or part B or whatever parts they are. It's applicable for the whole question. Be very, very careful over there. So now this dV by dt is 500 centimeter cube per second. And this one is how much? This one is centimeters per second. So now dV by dt is given. dH by dt is given. So what can you find? You can make dV by dH the subject. Again, leave it as it is for right now. We are looking for the value of V at this instant. I cannot find V unless and until I find H first, correct? So first work out H. This H is this much, and then I plug in this value over here. Now, some people would a little bit be shocked by what I have done over here. So over here, this is 25 plus H. So basically, I have plugged in this value over here. That's your choice how you want to proceed. Main thing is give the final answer correct to 3 significant figure. And that is how this question of rates of change is done. That is the first question. Now, the next question, that is about integration. So now let me add a page so that you can have a good, clear vision of how the question is all about. And let me first show you the question. Have a good look at this question. So now this question is about x-axis, y-axis, equation of the curve. There is this point B, there is this point A, then there is this point marked over here. The diagram shows part of the curve. The curve passes through these 2 points. Find the exact volume when the shaded region is rotated about x-axis. So now it's rotated like this and shaded region. So now if I work this out, we are looking for this region. But if I rotate this curve, then this region is also included. So this cross out region is also included. So therefore, volume of this cross out region, that is the limits 1 and 3 over 2, and this is y is equals to 1 square dy. Don't forget to multiply by pi. And volume of this blue and green region. So volume of this blue, that is this region, as well as this region, that is the total volume, that is equal to what? That is equals to pi, the same limit 1 and 3 over 2, and the equation is 4 over 2x minus 1. There is already a square. The whole thing is squared dy. Now let me also correct this thing. Okay, so now we are looking for the difference, and that difference is this the answer. So therefore, volume of only blue region, that is the difference between the two volumes. So this is just a strategy that I've written for right now. Let's look at this. First thing, volume under the curve. Just look at the working. Let me highlight the working for you. Okay. Then this thing goes on the outside. This thing goes up. Once the integration start, the integral sign disappears. And then you have increased the power by 1, divide by the new power, divide by coefficient of x. Chain rule is applicable because this is a linear expression. Then simplify first. Get rid of this negative sign, change the position of the limits. Evaluate, you get this answer. So, I mean, these answers, they do come in fractions. So your fractional working should be very good. Volume under the line, that is this line, that is y is equals to 1. Even after squaring, it is 1. Then integrate, plug in the limits, that is half pi. The difference is 11 over 6 pi. Now the next question. Now it says a triangle is formed from a tangent to the curve at B, the normal to the curve at B, and the x-axis. Find the area of this triangle. Now let me stop the working over here. And they are looking for the normal at B. This is the normal. This is the tangent, and this is the x-axis. We are looking for the area of this. Let me pause for 3 minutes, 4 minutes, and let's see if you can handle this particular question. Let me pause the recording. So now over here, let's look at the second part. It says a triangle is formed from the tangent to the curve at B, the normal to the curve at B, and the x-axis. Find the area. First of all, differentiate. You get this thing. X is 3/2. That is right over here. So this would be the gradient of tangent. Dy by dx, negative reciprocal would be gradient of normal. So now if I plug in 3/2 over here, that is -2. Gradient of tangent is -2. Gradient of normal should be +half. We all agree on this? Let's evaluate the equation of tangent. You can also work out with gradient only. This is equation of tangent. When line meets x-axis, y-coordinate is 0. X-intercept, y-coordinate is 0, y-coordinate is 0. You get x is equals to 2. You get x is equals to -half. So the normal is cutting x-axis as -half. The tangent is cutting x-axis at 2. This base is 2.5. Height is 1. Therefore, the area of a triangle is half into 5/2 into 1. That is 5/4 square units. So that is the working that is needed. A lot of stamina is needed. Can't expect this to be a short working. Now let's look at this question. This question is about the equation of a curve is such that the first derivative is this much, where a is a positive constant. The curve has a stationary point at a, comma, -15. Find the value of a. When it's a stationary point, we know that dy by dx is 0, whether it's a minimum point, whether it's a maximum point, whether it's neither a max nor a min, as long as it's a turning point, stationary point, dy by dx is 0. So just take this whole thing, equate it to 0. In place of x, write a. So let me write over here. I have plugged in a over here. I've plugged in a over here. Take common. A is 0. A is +4. Whenever there is a possibility of taking common, always take common. And then since it says a is a positive constant, that is why we are rejecting it. So 2 marks for this. Determine the nature of the stationary point. That is a basic kind of a question. You have to go for the second derivative. You plug in the value of x is equals to 4. It comes out to be positive. Positive means it's a minimum. Negative means maximum. Second derivative test. Positive means minimum. Find the equation of the curve. Now it's integration. Integrate each term separately. Simplify. Don't forget constant of integration. Plug the coordinate, which is what? Which is x is 4 and y is -15. When you plug this thing, what happens? You evaluate the value of c. That comes out to be 1. So let me just write it properly. So the value of c comes out to be 1. And then at the very end, write down equation of curve. Do not leave the answer as it is. Go to the very last step, plug things where they belong, and that is how you achieve it. Find the coordinates of any other stationary point. So whatever the stationary points are, they will be obtained from dy by dx. So dy by dx equals to 0. You can always take common, no issue with that. And now when it's equal to 0, you are just left with this middle term factorization. You get x is equals to 1. You get x is equals to 4. This was already given. So what is the other point? That is x is 1 and y is 12. And that is the answer for this part. So now that is about it. Now let me read a little bit of this thing. That is the examiner report. I think it's over here. Yes. So key messages, I always keep on highlighting it. Let me highlight it once more so that it's in your head. So now over here, okay. Previous reports have highlighted that the rubric on the front cover of the question paper states no marks will be given for unsupported answer from a calculator. Just show everything. For quadratic equation, it would be necessary to show factorization, use of the quadratic formula, or completing the square as stated in the syllabus. Using calculators to solve equation and writing down only the solution. writing down only the solution is not sufficient. It's also insufficient to quote only the formula. Candidates need to show the values substituted into it. Factors must always produce the coefficients of the quadratic when expanded. This is about middle term factorization. Similarly, with definite integrals, that means integrals with limits, a detailed method showing limits substituted must support the final answer. Using a calculator for integration is not sufficient, although it can be helpful for checking. Yes, of course, go ahead and check it. There's no issue. It's always advisable to read the question carefully. I mean, that is very, very obvious. Advisable. Read the question carefully to see whether later parts are linked with earlier parts. In some question, it was necessary to use values found earlier. And candidates should be reminded to take care of their presentation. Take care of their presentation. When candidates make several attempts at the question, they should clearly indicate which solution is to be marked by crossing out unwanted working. If there is insufficient space, they should use the extra page at the end instead of writing in small spaces within another solution. Now, there are all kinds of people in this world, so just don't be one of them. Clear working will minimize the risk of making errors through misreading their own work. Some of the answers were written in pencil, which is then superimposed with ink. Written in pencil, superimposed with ink, giving a very unclear image. When the script is scanned, centers are strongly advised that candidates are told not to use this. That means if it's not scanned, so no grade on that particular question because it's not legible. So this is no grade or no marks. Marks is better. So no marks on that particular question because the scanning is not complete. All good? So now this thing was there, binomial, theta, quadratics kind of thing. Okay, over here, F inverse. Okay. Let me highlight this. The majority of candidates did not appreciate that this question about rates of change required differentiation. So could be awarded no marks. Okay. So now question number 9 was that dv by dt question, dv by dt, dv by dh into dh by dt. If they cannot figure out who are these people, where do they come from, that it's about differentiation, they can be awarded no marks. Some did not attempt the question at all. Of those who did, a common error was to substitute h is equals to 10 in the volume formula. What is the correct thing? The h is equals to 10 in the first part was substituted in dv by dh. That was the correct approach. And of course, you know what the correct approach is. This is about part A. Only the strongest candidates successfully use the dh by dt from A to form an equation in H using the chain rule. After solving to find H, this was substituted into the volume formula. Solve to find H, substitute in volume formula. Volume given to at least 3 significant figures. Many candidates did not answer this question, but those who did often did not realize that differentiation was needed. The most common error was to substitute this thing. So we have already gone over the formula. This is just going over the wrongdoings of people. Question 10. In this question, candidates need to show all the steps in integrating V square. Why V square? Because this is a question about volume of revolution. That means there is a pi, there is V, there is limits, there is function in terms of X, the whole thing square dx. Including substituting of the limits 3 over 2 and 1 using the calculator for integration was not sufficient. Some fully correct solutions were seen with the volume of the cylinder subtracted correctly and the final answer given in exact form with pi included. Instead of cylinder, we integrate the line, square and integrate the line. Some candidates found the integral of y rather than y square, while others did not attempt to find the volume of the cylinder. They simply took it as all the way till the x-axis. Errors were seen in integration with the power reduced rather than increased. So what's the bottom line? Do not mix up differentiation and integration. Do not mix it up. and someone omitted the chain rule. Some candidates appeared to be unsure whether to integrate or differentiate. Okay. A minority of candidates produce fully correct solution, assisted by a clear strategy, logical working, and a diagram. This is the normal thing. Those who found the normal gradient often went in to find the equations of normal and tangent in the intercept with x-axis. Some candidates found the length of the sides of a triangle unnecessarily, not realizing that the height of the triangle is 1. Some found the problem-solving aspects of this part more challenging. Of course, there will be a challenging part, with many errors introduced, often through having an incorrect or no diagram. It is often advisable to sketch a new diagram rather than working with unclear annotations. How many times have I asked you people to do this thing in class? Make a small separate diagram. Do not mess up the original diagram. And even if you are messing up the original diagram, mess it up with a pencil so you can use an eraser. So whenever this option is there, pencil and eraser, that is the best option. A separate diagram is superb. A separate diagram is superb. And even if you want to work on that, just draw thin lines so that everything is visible. Many candidates omitted to use the chain rule when differentiating, as with the power errors were common. Then this question over here. Let me drink some water. Let me just check one thing. As usual, recording is all good. So now over here, successful candidates use the given information to substitute x is equals to a into dy by dx, set it equal to leading this thing. From this, they obtain a is equals to 4. Some use quadratic. Other candidates did not read the question. Most candidates found the second derivative, could be awarded the method mark. Some candidates had no a value to substitute, while others made arithmetic error. Wrong conclusion about the stationary points. Many candidates integrated correctly to find this thing, proceeded to substitute their x is equals to their a, y is equals to 15, for which they could be awarded this mark. Follow through, whatever. In this type of question, candidates should take care to write an equation correctly, not this thing to be awarded final mark. So 2x cubed minus 15x squared plus 24x plus 1. Okay, what they're saying is that do not write the expression, write it as an equation. That is the correct way. Okay, and do not leave just the answer you found C, that is, I think, 1, and then proceed to write the equation. I just emphasized this earlier. In this question, it was necessary to demonstrate a method of solving the quadratic form of the given dy by dx equals to 0, leading to x is 1, x is 4, and then to reject x is equals to 4 because this was already given. It was then straightforward to substitute x is equals to 1 in the expression to find the y coordinate. Large number of arithmetic errors were seen in obtaining the coordinates, even from the correct solution. So that is good idea. That will give you a good idea about rates of change, about tangents, normal, volume, stationary points. So everything was there over here. So now, in the next few questions, I'll just focus on the question itself rather than the mark scheme, because the mark scheme tells the same story that people do not learn from history. Now, question number 1. It says the equation of a curve is such that dy by dx is this thing. For x is greater than 3, the curve passes through the point 4, 5. Find the equation of the curve. So integrate this thing using chain rule. Don't forget to write plus c. Simplify. Plug in x is 4, y is 5. Let me simplify. Let me highlight this. X is 4, y is 5. Plug this thing in. Find the value of c. And don't forget to write equation of curve like this. Everything in the sidelines is written. Let's move on. Okay, next one, binomial and then quadratics. This looks like area. Yes, it is area. The diagram shows the curve with equation such and such. Now, indices, it's a very, very important part. What are the rules of indices that is needed over here? Let me highlight. Let me choose some new color today. I think this is what a power n into a power n, that is a m plus n. a power m divided by a power n, that is a m minus n. These are the first two rules which are very, very necessary. Let me put it in a box. Let me write two other rules. A power m into b power m, that is ab raised to power of m. A power m divided by b power m, that is a over b raised to power of m. These are the next two rules which are very, very important. Hold for a second. This causes trouble. I don't know why it's breaking down. Okay, that is the next thing. Now let me write over here the other rules. What are the other rules? The other rules are a power m raised to power of n, that is a mn. A raised to power of minus m, it's 1 over a raised to power of m. And we can also come across this a over b raised to power of negative m, that is b over a raised to power of m. So all these rules of indices are very, very important, and maybe we'll be using some of them. So now it says the diagram shows the curve with equations such and such for x is greater than 0. The curve meets the x-axis at this point. This is one point, that's the other point, find the area. So it's a simple area, it's a simple integration. First integrate, increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. There is a constant over here, simplify, this cancels off, this simplifies. Now x raised to power of 3 over 2, x raised to power of 5 over 2. So now let me grab some space and illustrate this thing once more. So now over here, when I have this thing, a power x raised to power of 3 over 2. So if I plug in 4, 4 raised to power of 3 over 2 can be written in two ways. 4 raised to power of half raised to power of 3, 4 raised to power of 3 raised to power of half. That is according to this rule over here. Got it? So now 4 raised to power of half is 2, 2 raised to power of 3 is 8, 4 raised to power of 3 is 64, square root of 64 is 8. You get the same answer. That's one thing. Similarly, let me evaluate 4 raised to power of 5 over 2. Again, two options. The first option is 4 raised to power of 5 raised to power of half. And this is 4 raised to power of half raised to power of half, raised to power of 5. Now, 4 raised to power of 5 is 2 raised to power of 10. So that is 1024. Do double check my working, raised to power of half. And this answer comes out to be 32, but this is difficult to think. 4 raised to power of half is 2, 2 raised to power of 5 is 32. So I'll go with this thing. The above two, both were easier. Over here, this one was easier. So now that is the working that is needed from the indices side. So now you plug in the upper limit. So now let me focus on the upper limit. So you plug in 4, you plug in 8 over here, and then you have a 0, the lower limit, and that lower limit is plugged in over here, everything becomes a 0. And this one is this thing 32 over here. And then you get this answer 64 over 3. This thing is written over here. The working that I did at the top, that is written over here. Now over here, let's look at this is functions. This we did that day, APGP, circle. That's too much of working. Question 11. Now it says the equation of a curve is this, where k is a positive constant, find dy by dx. So the first thing is pretty straightforward. That is 4x plus 1 raised to power of half. If half comes down, bracket remains as it is, power reduces by 1. Don't forget to multiply by derivative of bracket. Simple differentiation, simple differentiation. Dy by dx is this thing. Find the x coordinate of the stationary point in terms of k. Dy by dx is equals to 0. This thing equals to 0 and make x the subject. That's the x coordinate of stationary point. Then what is it asking? Yes, a lot of people have asked me this particular question. It says that given that k is equals to 10.5, find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of tan inverse 2 with the positive x-axis. Read the question once again. It's for 4 marks, but it's a little bit conceptual question. So now over here, they are using this concept that tangent theta is 2. If tan inverse of 2, basically we are writing it like this. If tan inverse of 2 is theta, let tan inverse of 2 is theta, therefore tangent of theta is 2. So it's kind of like that inverse function thing. Y is equals to fx, f inverse y is equals to x. It's exactly the same thing. So m is also dy by dx. So now this is dy by dx. We have the value of k as 10.5. I think this was 2k on the previous page. Yes, that's 2k. So 2 into 10.5 is 21. So now this equals to 2. Solve very simply without the calculator. X comes out to be 12. And what have I written over here? That is the threshold for this paper. So it was one tough paper. I don't think so. So it's not always that the paper is tough. It also depends on the quality of people who are giving it. So it's a combination of both things. So now when x is 12, y is this. So we plug in this equation, we get the y coordinate. And what are they asking? They are asking equation of normal to the curve. So equation of tangent is 2. Equation of normal is -half, and that's the equation of a line. No need to expand it because they are not asking in any particular format. So now this thing over here, which paper is this? This is May, June 2023, variant 1-2. So let me write in the group. Hold for a second. So this is the tan inverse of 2. This question is this all good, all clear? Okay, I'm just waiting for your response. And then there are some WhatsApp messages. I can also read that. Acha ji. So now someone asked this question, if we do working with pencil and let me take a screenshot. Hold for a second. I'm not sure whether this, just hold for a second, people. Let me answer this thing. Save to photos, go to the photos. Copy. Okay, now let me add over here. Someone asked this question, if we do working with pencil and only final answer with pen, then is it okay? My approach to this is no. Work in pen from the start. And when you are looking at a question, let me do some illustration over here. Hold for a second. Now, let's say the question is like this. These were lines of the question. And over here, you have written something like this. That's too thick. You have written something like this, something like this. This is the question itself. And over here, if you want to underline, maybe highlight this part with a pencil, that makes sense. When you draw diagrams, of course, it has to be with pencil. So underlining, that is perfect. But think first and then work it out in pen, because you will be wasting your time. So do not work in pencil like I have done over here. For example, there was one question in which I have done the working. Uh, let me go up and let me show you which question am I talking about over here. Let's say in this question, I have done this working for this. So this working on the sidelines, you can do it in pencil because this is kind of rough work, but on the sidelines. And then when I have to substitute over here, this is 4 raised to power of 3 over 2 is 8. 4 raised to power of 5 over 2 is 32. So this you can write it over here and the working can be done on the sidelines. I hope I've answered that question which someone has recently asked. So now let's look at this paper. This is May, June 2023, variant 1.3. And let's focus on this. Another question. A curve which passes through 0, 3 has the equation y is equals to fx. It is given that f prime x equals to 1 minus this thing. Find the equation of the curve. Again, just focus on the working. There is nothing to teach over here as such. It's just I'm pointing out the things which you should avoid in order to achieve the A star and the A's that you deserve. In A's, there is no A star, but that very high A will directly be proportional to the A star in A2. So that is what I'm pointing out. So look at the working. I'm not even using a highlighter. Take the bracket up. Constant remains as it is. If there was 1 over 2, that constant would remain as it is. The algebraic term expression would go up. Then apply chain rule. Then apply basic integration. Write the constant of integration. And then simplify. Then plug in the values. Evaluate C. And then write fx at the very end. Sometimes they give you dy by dx and then you get a y. Sometimes they give you f prime x and you get fx. So that is the first part. The tangent to the curve at 0, 3 intersects the curve again at one other point P. Show that the x coordinate of P satisfies this equation such and such. So now x is 0. They have given the tangent to the curve. When x is 0, f prime of 0 is coming out to be 3. That is the gradient of tangent. And then x coordinate is there, y coordinate is there, gradient of tangent is there. You find equation of tangent. So it intersects the curve again at one other point P. So now solve it simultaneously with the equation of the curve, simplify, and this is what you get. They're not asking us to solve it. They are simply asking us show that. So this is part B. Is there a part C? Yes. Verify. So now the word verify, it means plug in and check. They are not asking us to find. They are asking us to verify. They have given us the solution. So when x is 3 over 2, just plug it in over here. And this comes out to be 0. It's fulfilling this equation. And find the y coordinate of P. Now plug the x coordinate in equation of curve, and then you find the y coordinate. You can leave the answer as it is. If you want to write it as a coordinate 3 over 2, 15 over 2, or write both things in decimals 1.5, 7.5, that is also good, also perfect. Now this question about area or volume, which one is that? This is a maximum point. This is normal. This is area. Okay. Now, let me just go to one thing, because something has not appeared for a long time. And that is about, not integration, that is about this thing, which is the stationary points concept. And that is about the diagrams and everything. Not here. This is not the one. So there is this thing, differentiation, stationary point. Then there is this thing. It's also one other one new. Yeah. So I just want to focus a little bit because it's been a long time that they are asking questions on this. Someone even asked this question to me. So let me explain this question. Let me look if there are other good ones also over here. Yes, one or two good ones. Okay. So let me just finish that question and come back to it. And over here, let me again focus. This one is a nice question, and I'll explain this. So two questions, three questions from this type. So now, not this thing, my bad. This is coming up soon. And where is the thing? Transfer questions. And just looking for this thing. Where is it gone? S2. Okay, there it is. So now let's look at this question and maybe some more difficult ones with indices in it. So I think this is a pretty basic question. The diagram shows the points A, B lying on the. So now it says the diagram shows the point A, B lying on the curve with equation such and such. Find the coordinates of the maximum point. That is differentiation. You differentiate, simplify, make it equal to 0, solve this equation, you get 1 point. Coordinates, that means the y also. So don't forget that. Also, advisable to read the marks. 4 marks means there is some sort of solid working. Of course, 2 mark, 1 mark, 3 mark, 4 mark, 5 mark, 6 mark, everything is solid. But 4 marks means elaborate working. So basically 1 mark over here. Simplification is 1 mark. Finding x coordinate is 1 mark. Finding y coordinate is 1 mark. Then it says verify that AB is the normal to the curve at A. So now what do I have? I have the A coordinate. I have the B coordinate. Just go ahead and find the equation of the normal. It should pass through this. So now what do we do? The normal is at what point? Normal to the curve at A. So dy by dx is given. Plug in x is equals to 1.5. So let me show you. That means over here, plug in x is equals to 1.5. dy by dx is 3. That is gradient of tangent. And gradient of normal is the negative. Gradient of normal is the negative reciprocal. So now we have A, we have B, we have gradient of normal. We find the equation. Now plug in B. It should satisfy. So basically, I have used the concept of verification over here that AB is, yes, the normal of this curve. Find the area of the shaded region. So area of the shaded region, it's your choice whether to find the area under this line or find the area of this trapezium. So 1.5 to 7.5, that is 6 units. That is the base or the height. This is one parallel side, which is 5.5. This is the other parallel side. The length is 3.5. So find the area of the trapezium. That's over here. And then find the area under the curve between these two limits, 1.5 and 7.5. From it, subtract the trapezium. You find the area of the shaded region. So area under the line, area under the curve, limits are over here. Integrate, chain rule, plug in the limits, take care of it. Again, this is 16 raised to power of 5 over 2. This is 4 raised to power of 5 over 2. That was done earlier. So maybe at some point I might have done this. No, this is something else. I think I just made some P3 working over here. So 16 raised to power of 5 over 2. Let me write it. 16 raised to power of 5 over 2. Let me correct it. Can be written as 16 raised to power of 5 raised to power of half, 16 raised to power of half raised to power of 5. This is easy, work it out. So 4 raised to power of 5 is 1024. So 4 raised to power of 5 is 1024. I have not shown the steps over here. It's better to show this. And 4 raised to power of 5 over 2, that was already shown, that was 32. And you get this particular answer. So now let me look at some other question which might be a bit difficult. This is again rates related to this cube, that is normal. This was done that day in class. It's done. Mhm. Now let's look at this question also, and then I'll go to those word problems because we have to spend time on that February, March paper also. So let's spend another 20 minutes on these kind of questions. The diagram shows the curve with equation such and such. The curves intersect at point A and B. Find the coordinates of A and B. This is 3 over root x plus 12. This is 2 root x 13 over root x. They both are equal to y. And grab this thing from here. Let me just highlight this. So now what do we need is that this is your y. This is your y. You equate them. So 3 root x plus 12 equals to 2 root x plus 13 over root x. And then you simplify. And what are you getting? You are getting a disguised quadratic equation. The power is 1. The power over here is half. And you make a substitution. Let m is equals to root x. Therefore, m square is x. You solve this quadratic equation. This is middle term factorization. You get two values, m is 1, m is 5. But m is root x. So root x is 1, root x is 5. Therefore, x is 1, x is 25. Are they asking for coordinates of A and B? Yes, there are two coordinates. One of them is A, the other one of them is B. We need the X, we need the Y, we need the X, we need the Y. So this is X, this is Y, this is X, this is Y, coordinate 1, coordinate 2. Now, the next part should either be volume or area. Find the area of the shaded region. So integrate the top curve between limits 1 and 25. Integrate the bottom curve between 1 and 25. Simplify, write down the answer. I have forgotten to write for individual parts. The difference is 128 over 3. So let's skip this. Let's move to this thing. Stationary points. Let me just reduce the brightness a bit. Now look at this question. This is from our topical book. Now the question is about this. It says the diagram shows the curve with equations such and such. The minimum point on the curve has coordinates a comma 0, and the x coordinate of the maximum point is b. So this is this thing, this is this thing, where a and b are constant. State the value of a, find the value of b. Why does it say state? Because it is so obvious, because it's touching the x-axis. Not only it's a minimum point, it's also an x-intercept. Therefore, y is equals to 0. Therefore, x is 0. X minus 2 whole square is 0. Therefore, this is x is 0. This is x is 2. Got the idea? Find the value of b. That is your traditional way. You have y prime, make it equal to 0. Simplify. One of the answer is 2. One of the answer is 3 over 2. So therefore, this is 2 and this is 3 over 2. Actually, it's 2/3. So this is 2/3. Let me correct myself. 3x is 2. Therefore, x is 2/3. So this is 2/3. This is 2/3. That is one thing that's done. Something like this did not come for a long time. Very high chance. The non-variables x, y, and u are such that u is x square y. So u is x square y. Given that y plus 3x is 9, find the stationary value of u and determine whether it's a max or a min. So y and x, two variables are there. U is a third variable. So now I can either write u in terms of x only or u in terms of y only, because I need two variables at a time. So now the brightness has gone down a lot. So now if I make y the subject, that is 9 minus 3x. If I make x the subject, that is 9 minus y over 3. U in terms of x, you get this. U in terms of y, we get this. If I have u in terms of x, I get du by dx. So let me correct myself. So 3 into 3. Hold for a second. So now over here, this is du by dx, 3 into 3, that is 9x squared. And then over here, this is the derivative that you get. You make it equal to 0. you find the value x is 0, x is 2, you find u as 12. The same thing can be done over here also. So you have a choice, u in terms of x or u in terms of y. I think these are the normal kind of questions. Let me still double check. Yeah, this one. Now over here, the diagram shows an open rectangular tank of height h meters covered with a lid. The base of the tank has sides of length x meters and half x meters, and the lid is a rectangle with sides of length this much and this much. So, of course, the lid is out of that thing dimension. The box is inside, it's jutting outwards. The external surface area of the tank, that means there are 4 side walls and a base, that's the external. The top is covered with the lid, you treat the lid separately. The external surface area of the tank together with the area of the top lid is A. Express h in terms of x and show that given that x can vary, find the value of x for which A is a minimum, showing clearly that A is a minimum and not a maximum. Okay, very comprehensive question. First of all, if I talk about the tank holds 4 meters square of water, so it has nothing to do with the lid. So there is x, there is half x, there is h. X half x, h is equals to 4. Therefore, h is 8 over x squared. Why did I make h the subject? Because the area is in terms of x and not h. So get rid of h in the beginning. Be very, very clear about it. The tank lid, that's a rectangle. That is 4/5 into 5/4. Nice numbers. They cancel out and we are left with x squared. The tank has 4 walls. This is x and this is h. That's the front and the back, 2xh. This is half x, this is h, this is right wall, and there should be a left wall over here. And then the base is x into half x like this. That is the base square. So you have to look with a 3D vision. And you get this thing. That is the area of the tank. That's the area of the lid. Now add it all up, replace h with 8 over x squared, simplify, you get this. Now, 2 things that comes a lot in differentiation, that is derivative of root x is 1 over 2 root x, derivative of 1 over x is minus 1 over x squared. Okay, so I have not done the next part for some reason. Let me just continue with the next part. So now we have A as 24 over x and 3 over 2x squared. Let me evaluate A prime or dA by dx. 24 over x, that becomes minus 24 over x squared based upon this. And 3 over 2x squared, that is 3 over 2 into 2x. How much is that? That is negative 24 over x squared, and this is 3x. Let me also differentiate it once more, d squared a over dx squared. So minus 24x minus 2. So let me write it as like this, minus 24x minus 2 plus 3x. Because you need this format for differentiation. Negative 24, negative 2x, negative 3 plus 3. This is positive 48 over x cube. I'll soon pause for Azan when it's clear. So now if x is positive, of course, it will be a positive value. So d square a over dx square will be positive. Therefore, it's a minimum and not a maximum. It's a minimum and not a maximum. That I have done even before I evaluated x. Why? Because x is a dimension. It will be positive. Now, let me take dA by dx. So dA by dx, that is minus 24 over x squared plus 3x. So minus 24 over x squared plus 3x equals to 0. dA by dx equals to 0. We get the stationary points. So minus 24 over x squared is equals to negative 3x. And positive 8 is equals to x cubed. Therefore, x is positive 2. And what else are they asking about? Find the value of x for which a is a minimum. Show clearly that a is a minimum, not a maximum. And if they ask for the value of a, so 3 over 2x squared plus 24 over x. So a is 3 over 2x squared plus 24 over x. This is extra stuff that I'm doing if they would have asked for a. So x is 2. Therefore, A is 3 over 2 into 2 into 2 plus 24 over 2. So this is 6, this is 12. Therefore, the area is 18, whatever is the unit. Meters. So this is 18 meters square. That is the minimum value of area. Now, let me remove this PDF and let me show the last question over here. Okay, let me first plug this thing in, because these questions, let me show you two questions, just the proving part, because it's been a long time that they have come. Or maybe let me keep one thing for tomorrow. So now it says the diagram shows an open container constructed out of 200 centimeter cube of cardboard. Open container, that means the top is missing. The front is there, the back is there, the side wall is there, another side wall is there, and now it's azan from my masjid, the close by. Let me pause the recording. So now this particular question, show that y is this much, all the other dimensions are given, show that the volume is this much. And then it's the basic differentiation thing. First thing first, I think it's done over here. Let's deal with the triangle. This is 8x. These two are equal. Isosceles triangle. If I drop a perpendicular, it will be bisect equally. That's a property. This is 4x. This is 5x. This is h. Pythagoras theorem. This comes out to be 3x. Therefore, front and back, that is half into base into height. The same thing, half into base into height. Area of side wall, that is 5x into y. So this is 5x and this is y. And the second wall is also this. So there are just 4 sides. The total surface area is this. We already made h the y the subject from here. So that's the first thing. And then volume of prism, cross-sectional area, that's the area of the triangular prism, into height or length. It's lying down, it's the length. So that is the length, that is cross-sectional area, that is how you get it. So I think that's a very, very comprehensive overview of differentiation and integration. So let me pause the recording over here so that we can go to February-March paper 2025. So let's meet in few minutes.